This video is to review functions and function notation. A function is a relation. So first we need to know that a relation is any set of ordered pairs, which are just points. So points on a graph or points in a table. We write those x comma y. So every x value, which we call input, has exactly one y value, which we call an output. If it's a graph, we can test this with the vertical line test, and we know that if x does not repeat with a different y, then it's a function. So in these examples, I have a table for A and B. And in table A, I see -1, 4, and -1, 7. So since x repeats with a different y, first it has a y value of 4 and then 7, this would not be a function. Table B, when I'm looking at the x values, I have 9, 3, 6, 0, 8. Since none of the x values repeat, then this is a function. Same thing for my list of ordered pairs. I'm going to look at the x values, -1, 2, 0, 3, -3. None of those repeat, so this is a function. And for part D, I have 0, -9, 2, 0, and 1. And so these 2 points, 0, 4, and 0, -2, the x value repeats with a different y, so that means it's not a function. When we look at graphs, we look to see if they pass the vertical line test or not, and what that is if I can draw a vertical line through the graph and it crosses more than once, it's not a function. And the reason for this is, if I were to draw 2 points here, they would have the same x value. This is -6, 4, and down here, this is -6, -4, and so the x value repeats with a different y, and so it's not a function. This parabola is never going to have that occur. There's no vertical line that would cross it more than once, so it is a function. My circle right here crosses twice, not a function, and this line, you can never draw a vertical line through this graph and it crossed more than once, so it is a function. All right, function notation. F of x is the output, or y, and x is the input. So it's the same thing as y, f of x is. F of x is pronounced as f of x. And so in order to use function notation, all it's saying is, hey, whatever in the parentheses, just plug that in for x. And so here I have -2 in my parentheses because it gives us if f of x is 3x minus 1, find f of -2. And so I'm just doing my fancy notation here, and I'm plugging -2 in for x, and I'm evaluating. So I have 3 times -2 is -6, take away 1. This would give me -7, and we typically write our final answer with that fancy function notation, which again just means plug in whatever's in the parentheses in for x. So we make this more challenging when we have an expression in the parentheses. So I'm going to plug in x plus 3 for x, and so now I have f of x plus 3, meaning I'm plugging in x plus 3 for x, 2 times x plus 3 plus 4. I'm just plugging the expression in where x goes, and then I'm going to distribute. 2 times x is 2x, 2 times 3 is 6. Drop down the plus 4 because it's not in the parentheses. Combine like terms. I have 2x plus 10. And then the last step is to include that fancy notation in my answer. Number 4 is more of an algebra 2 level or math 3 level problem, depending on what state you're in. And so here I have f of x minus 1 is what I'm plugging in. This is going to go where x is. And so I'm doing x minus 1 squared minus 3. When you square a binomial, and a binomial is something that has 2 terms, and I have an x and a -1, I have to write it out twice. I can't just square those individual terms. I have to actually distribute. So I wrote the parentheses out twice since squaring means multiply by itself, and I'm going to distribute. And then I'm going to combine my like terms. -1x and -1x make -2x. 1 take away 3 gives me -2. And I'm going to include my fancy notation in my answer. All right, moving on. More function notation here. Sometimes we might be asked to compare functions, and when we do this, we would just plug them in and figure out what their values are. And so if I was going to find f of 4, I'm going to do 4 squared, which is 16. If I wanted to do g of 4, I would have 2 times 3 to the 4th. And I'm just going to type that into my calculator quickly, and that would give me 162. And so I can see that g to the 4th is greater than, so that would mean g of 4 is greater than, so f of 4 is less than. If we want to find an input when we're given output, we're working backwards. And so for this problem, I'm going to set it equal to 11. So I have that f of x is 11, so I can replace f of x with 11 since they are equivalent. So I'm going to do 11 equals 2x minus 3. And then I'm going to solve for x because it tells me to find x. So that's 14 is equal to 2x. And that gives me 7. Sometimes you'll see this rewritten with that fancy notation with x on the inside. So if it was a standardized test, you might see that. All right, another problem where I'm given the output. It says find the input if given the output. So I'm going to set it equal to 22. Because it says g of x is 22. This is more one of those higher level algebra where because you have an x squared term. So I'm going to add 3. And then to get rid of a squared, we square root. And so x would end up being positive or -5, because if you square root 25, it could be 5 or -5, because 5 squared is 25 and -5 times -5 is also 25.